A warm welcome to one and all. Myself Yaspi, my batchmates Kiranmai and Kausalya from Veltech Multitech Dr. Rangarajan, Dr. Soundala Engineering College from Electronics and Communication Engineering are going to present our final year project on the topic dehazing and enhancement of underwater images using adaptive median filter. So in our project, generally the underwater images taken will be of low contrast, noisy and hazy in appearance. So first we are going to remove the haziness present in the image by using effective dehazing algorithm. Here we are performing white balancing and contrast enhancing methods. So the obtained fusion image will be of haze free but it will be containing some noise. So to remove this noise present in the image, we are using denoising method by using adaptive median filter. In this, we will be obtaining and estimating MSC and PSNR value by comparing the PSNR values with the coming further outputs. We knowing that our PSNR value is increasing in this proposed project. So in this slide we are going to explain how the noise is getting added into the images. So generally the underwater images which we are taking will be getting degraded by absorption and scattering processes. Normally let me explain how the image is captured in the camera. First, in an underwater scenario, the light is received by the camera by mainly of three components. It is of a direct component, a forward scattering component and the backward scattering component. First, in the direct component, the light is getting reflected directly from the objects and it is viewed by the camera. In the second one, a forward scattering component, in that the light will be randomly deviating when it is reaching the way onto its camera. But in the third one, backward scattering component, before the light enters hits the object, it will be getting reflected on the way to its camera. And also the noise will be added by the microscopic floating particles present in the image. So these are the factors which is increasing the scattering effect and it will be added as a noise present in the image. And these are the papers we have referred for our project. And first, the main paper is underwater image enhancement by dehazing with minimum information loss and histogram distribution pair. In this, what we have understood is it increases the contrast and brightness of the image and also it will produce a haze-free output. But also it will have some disadvantages in the paper, like the effect of noise is not completely removed and also the image under low conditions which we are taken is of not clear visibility. And the next one is the next paper is of median filtering. In this we can able to remove the noise present in the image by preserving the edges. But in this paper the disadvantages, it must be the pixel will be of constant value, so it is of difficult to obtain the traces. And these are the papers and we are going to the next slide. So this is the original existing method. First, the original image is taken and which is subjected to the image dehazing process. And as we said that in image dehazing we are performing two methods like white balancing and contrast enhancement. In white balancing, what is going to do is it is going to enhance the appearance of the image by discarding the unwanted color cast present in the image. And the next one is color contrast enhancement, is just going to amplify the visibility of the image and it is going to remove the haziness present in it also. And finally, by performing the fusion process, you are going to get the fused image, which is the dehazed image. And after that, we are going to estimate the PSNR value by using the formula 10 log to the base 10 255 square divided by MSC. This 255 is nothing but it is the grayscale value and MSC is the mean square error. And the mean square is nothing but it is the difference between the original uncorrupted image and the observed image. And then we move on to the next slide. So this is the original existing image dehazing process. First, the original hazy image and the noise image is taken and further it is obtained as two input images in the following processes, that is by white balancing and the contrast enhancement. After that, the Obtained both inputs are weighted by three weight maps, that is luminance weight map, chromatic weight map and saliency weight map. First, in the luminance weight map, it increases the luminance by balancing the brightness, and the second one is chromatic weight map. It increases the saturation value and it is increasing the colors visibility present in the image. In the saliency weight map, it highlights the edges present in the image. So after performing these weighted maps, by using fusion process, we are going to fuse the both inputs and we are going to obtain the original output image, that which is the dehazed image by this fusion process. So this is the example we are going to explain you. First, the hazy and noisy input image is given to this process. So after that, the input image is divided into two inputs, like white balanced input and contrast enhanced input, and I have explained you what happens in both of the inputs as a process. So I move on to the next slide, and this is the first input, and which is we going to weighted by three weight maps. First one is luminance weight map, and the second one is chromatic weight map, and the third input is the saliency weight map. So after performing this, again the second input is taken and it is also just converted into the equivalent output by using these three weight maps. And the next slide is, so after performing the three weight maps to the first and the second input, and by performing fusion process, you are getting this dehazed image as the output. And the next slide is, so this is the example in the low light condition. So here we are explaining how the image is getting haze free, and but still the noise will be present, and also we are able to explain it as a demo in this slide. This is under near water surface, this output sample is, and this is also finally after performing all the processes, we are getting the dehazed image as the output. And the next slide is, this is our PSNR value, what we are getting by this process as a dehazed output. In this, by using the three samples, in this the value will be of 69.0542 and 69.2156 and 69.1721. So this will be of low PSNR value, and further we are going to enhance this PSNR value by the next our existing into our proposed work, as it will be explained by my batchmate Kiranmai.
As we have seen till now in the dehazing process, the noise is not totally removed, but only the haze is removed. And there is another drawback that when the image is taken under poor light condition, the underwater images have low brightness, that is low visibility. And there is another drawback, that is the peak signal to noise ratio is also very low. And to overcome all these drawbacks, we are going to use a denoising method. In this denoising method, the noise from the image is totally removed, that is only the noise is removed. And here the PSNR value is also estimated to be high. We are calculating PSNR value because for an image to have a good appearance, it must have high PSNR value and low MSE value. Here MSE is the mean square error, that is the difference between the original image and the processed image must be low. Then the PSNR value will also be very high. So to get high PSNR and to remove noise, here we are going to use adaptive median filter. As from the name, adaptive median filter, window size is adaptive. So the window is placed on a part of an image or on a whole image. So it replaces, what it does is, it replaces the pixel value of the original image with the median value of the window. Gradually, the window is taken as odd values, that is generally of 1 cross 1, 3 cross 3 and 5 cross 3 and so on, 5 cross 5 and so on, because it is easy to define median value in an odd odd number of window values. But if we take the window size has to be an even value, then two medians will occur and it will be very difficult to decide on the median values. So we are using here adaptive median filter. So the purpose of using this adaptive median filter is it removes the impulse noise which is generally or commonly known as salt and pepper noise. And this adaptive median filter not only removes that particular salt and pepper noise, it also smoothens other noises as well. And it also reduces distortion, that is excessive thinning and thickening of an object boundaries. Okay, next we are going to learn about what is salt and pepper noise. The salt and pepper noise is generally added to an image where there is a noise in an image, that is for example, two adjacent pixel values change rapidly, that is they have a very big difference between them. So the on that noise black and white dots appear on it. So so to reduce this salt and pepper noise, we are going to use median filter. And this is the block diagram of one part of our proposed system. Here we are going to take as usual the hazy and the noisy image, and we are going to apply it to an adaptive median filter, and then it goes to the masking, and after masking process only the noise from the image is removed and not the haze. So and we are going to calculate the PSNR value for that noise free image. And this is one of our output, that is first diagram is our first image is our input image, and we are going to add salt and pepper noise. This salt and pepper noise, as I said before, will be applied only to the noisy pixels, and then we are going to apply mask, that is window, that is of as I also said before, it must have an odd value. That we have taken here is 3x3, and we can see that noise is removed and the image is bright and clear. This is our second output, that is this image we have taken under low light conditions, and we can also see that salt and pepper noise is added, and we have done 5x5 masking. And below the output image 3, we have taken this image near water surface, and this also gives good results. And this is the tabulation of a denoise image, that is we can see that PSNR value is high, that is 92.63, 89.00 and 89.27 for 3 images. But before in the existing method, dehazing method, we've got some values around 68. So we can see that the noise is totally removed, that is signal value, each pixel signal value has been enhanced here. And this is the total block diagram of our entire proposed work. Here we are going to combine both the dehazed and the denoised method, because as we have seen in the proposed work in denoising method, only noise is being removed but not haze. So we are going to remove haze as well as noise with this dehazed and denoised method. Here from the block diagram, we are going to take a hazy and noisy image as an input. Then we are going to do dehazing process. From that we will get haze free image, but noise will be there. So to remove noise, we are going to process it by using denoising method, and then after that we are going to remove noise, and as we have already removed haze, the output image is totally free of noise and haze. And to say that our proposed method is effective, we are going to compare the PSNR value of only dehazed image and the PSNR value of the dehazed and the denoised image, and we can see that the PSNR value of proposed project is high, as increased. So this is the dehazed and denoised process of input image 1. So for first image is input image that is full of haze and noise. Then we are going to split that image into white balance and contrast enhancement, and then the next 3 continuous images of is chromaticity, saliency and luminance image of input 1, and the successive 3 images are the same for contrast enhancement, and the next image we are going is the dehazed output, and to that we are going to add salt and pepper noise, and we are going to get we are removing both salt and haze from that image. And this image is for low light condition. Here we can also see that PSNR, that is the pixel value has been increased, pixel strength has totally been increased, and haze is also removed. And this is this image we have taken under taken near the water surface. This also has increased our PSNR value. Let us see these PSNR values now after this proposed work. Here we can see that first after gray value, PSNR value of haze-free noisy image is 69.0542, and the PSNR value for both the dehazed and denoised image is 72.1387. So there has been a 4.4667% increase in the PSNR value. That is some more noise has been removed than the existing method. The similar is for similar values is for the other 2 images. So now let us come to the applications. So as we have seen that PSNR value is high, and noise is removed, and haze is also removed. So we can use this method in many applications, such as pipeline inspection, where the cracks in the pipes can also be monitored, and also for researchers to study about the underwater structures, we can use this method, and also to monitor underwater organisms, we can also use this method, and underwater imaging using sonars also we can use this method. So these are the references that we have surveyed till now for this project. Thank you.
And thank you so much for listening our project. Hope you all understood well, and if you have any queries, you can contact us to our mail.
Thank you.